Welcome to the tutorial. In this video I'll be showing you how to make 3D Geometry Dash. Now I highly recommend before watching this that you watch the 2D Geometry Dash tutorial that I made on my channel, because if you watch that you'll have a much easier time understanding this tutorial. But if you don't want to watch it, I'll also be explaining what I'm going through in this tutorial as well, but I just recommend that you watch that first. Now getting to 3D Geometry Dash, this will not just be a 3D looking Geometry Dash. This will be an actual game where you can move from side to side as well and interact just as you would in a 3D world. So this will not just be a visual effect. This will actually be a gameplay effect to Geometry Dash. Now the first thing we're going to do is of course create the player. So I'm going to add a new object, and instead of adding a sprite like we usually do, since we're in 3D and we're going to be using native 3D, not Pandockle extension, we're going to be using a 3D box for the player. And of course I'm going to name this player, and by default its size is going to be 75 by 75 by 75. And for tutorial sake, I'll show you how to make things your own, but for tutorial sake, just follow along with the settings I have right now, and that'll make things work smoothly. But I will be explaining what you need to change just in case you want to change these values. Now we want no lighting effect. We don't want to react to lights. And when we have a 3D box, you'll see that we have all these faces, which are the size of a cube. And of course, a cube has 6 sides. So for the front face image, I already have these images pre-made. All it is a yellow sprite. We're going to just be basically playing a yellow block. So all you have to do is go to pixel. Of course, my pixel, like always, is broken. But of course, if you can go create your own yellow sprite by going to pixel yourself. And I'm just going to be simply going to my colors right here. And I'm going to just fill in yellow for all of these. And now that I'm done with filling in yellow for all the cubes, I'm going to apply, and I'm going to drag this onto the scene. And right off the bat, you can already see that this is actually 3D. If I look around, it's kind of hard to tell because it's the same color. But if I look around, you can already tell that this is a 3-dimensional object. So that's good. The second thing we're going to do is get some ground. I'm going to add a new object. And this is also going to be a 3D box as well. I'm going to call this ground. And we're going to go into material, no lighting effect once again. We want to show all the faces. We don't want any of them not to show. And I'm going to have this in a Google Drive link that you can go in the description that has all the sprites that you need. But for now, I'm just going to pick up this block that we have here. I'm going to go find where we have it. So I'm just going to go find this. And this is some ground. This is actually from the Geometry Dash game. It's not going to look exactly how it would. I'm going to stretch it out. But you can use this ground. Or you can use whatever you want. But preferably this color, because we don't want that blend in with the background 100%. And speaking of background, I'm going to go into the background color and change it to like a blue. Almost like a lightish blue. So because we don't want everything blending in with each other. So we don't want to just keep it a plain white. So I'm going to drag this ground onto the scene, and once again, you can also tell that this is 3D. I'm going to drag it out horizontally so we can have some more space. I'm going to drag it out, and here we have it. We have it dragged out like this. So this is a good length right now. And also for the setup, we also want a block object. We want a block object because we're going to have a base ground, and then we're also going to have a block that we can jump on. So this is also going to be a 3D box once again. I'm going to call this block. And we're going to once again make sure we show all faces. And for this image, I'm going to use a different image. Going to my test sprites and going to Geometry Dash. Once again, I'll have this in a Google Drive link. You can download all of these assets in there. And here we have just a block that I made. So I'm going to fill in this for all of the faces. And after that, we're going to make the camera. So we filled it in here. And I'm going to just drag it onto the scene. We're not going to use these yet. We're just setting everything up right now. So next thing we want to do is add the camera, because since this is a 3D game, we also want to have a 3D viewpoint, because if we have a 2D viewpoint, it's going to be hard for us to actually see exactly where the player is going. So I'm going to add a new object, and I'm going to call this, of course, this is going to be another 3D box. It actually doesn't have to be a 3D box, but it's better for it to be a 3D box because you can see it in the scene better. So I'm going to make it a 3D box once again. I'm going to call this camera. And I'm going to show every face, and we're going to choose a file, and for this I'm going to just make this a blue cube. Once again, it doesn't really matter too much about what these colors are. It doesn't matter how they really look. You just want to make sure that you can recognize everything and that everything is different. So I'm going to finish in filling everything in here. And here we have it. We have the camera done. We have the camera, we have the player, we have the ground, we have the block. I'm going to drag all these onto the scene. Now, in order for it to set up more things, let's first set up the player. So for setting up the player, I'm going to go into behaviors. I'm going to add behavior. And we're going to be making this player a physics object. So I'm going to be using the physics engine. And there's two things that we want to check off here. Can sleep. Can sleep is not too important, but it's just better for performance. And we want fixed rotation. Now, if you watched my earlier Geometry Dash tutorial, I didn't use fixed rotation. And that's because I had rotated it just naturally. But in this case, I'm going to explain why it's better to use fixed rotation. It's because the player will be rotating on his own because it reacts to forces. So when you land on the ground, it'll still kind of be tumbling a little bit because reacting to it landing on the ground. So by having it fixed rotation, we can make the player rotate and move exactly when we want to move. So that's why we're using fixed rotation this time instead of just non-fixed rotation. Now, here we go. We have the density. I'm going to keep this at 1. And the gravity scale, I'm going to put it at 2 because we want the player to kind of fall slightly faster. For tutorial's sake, keep your settings the same as mine. But once again, you can edit these after the fact once you understand what's happening. Now, restitution is the same as bounciness. I'm going to set the restitution as equal to 0 because we don't want the restitution. We don't want any bounciness for our player. And the friction for our player is also 0. We don't want it having anything that's stopping it from sliding across objects. The linear damping and angular damping, what these are, linear damping basically controls the resistance, how much the object will resist moving linearly, like up and down or even left and right. So since we don't want our object to resist at all, we're leaving it at 0. The higher we go, the more resistance it has. Same thing for angular damping. It's the same thing, but for rotation instead. We don't want the object to resist rotating, so we're going to keep this at 0. And that's the first behavior that we have. That's the only behavior that the player is going to have. And, of course, make sure this is a dynamic physics object. And also, for variables, we're going to set all of these variables up right now for the player. Now, once again, if you've watched the first tutorial, you'll easily understand what these are, and you won't really have to, you won't need my explanation, but just in case you haven't, we're going to first set up a Boolean variable, and I'm going to call this can jump. This will just be a variable that checks whether or not the player is able to jump, depending on whether or not it's on the ground. Also, we're going to have a variable, and this is going to be a number variable, and this is going to be called angle. Now, angle is going to be used for rounding up the angle of the player because, of course, a value of the player's angle is going to be like a decimal value that's really long, and we want exact values so we can measure them better. So I'm going to put this as a number, and we're going to have that rounded up later. And nearest angle, this will be used for controlling the player when it's rotating in the air. Like if you've played Geometry Dash, you know the player rotates and it snaps to the closest angle when it lands on the ground. So the nearest angle is also going to be a number variable that's called 0. And I'm going to make 4 variables. Well, 3 more right here. 1, 2, 3. And I'm going to call these snap. The first one's going to, of course, be called snap 1, snap 2, and then we're going to have snap 3. So I'm going to name this snap 2, and then we're going to have snap 3 right here, and then we're going to have snap 4. Now, the snap variables, of course, these are used for, once again, controlling and measuring which one of the angles, 90, 180, 270, or 0, which one of those angles the player is closest to so it knows where to snap. Once again, these will all be number variables that are by default set at 0. So these are all going to be set as number variables. And for the last variable, we didn't use this in the earlier tutorial because, once again, I kind of fine-tuned a little bit. It's not perfect yet, but I fine-tuned the platformer, the jumping engine, and the way that it rotates. And we're going to have another variable, and this is going to be called, this is going to be a Boolean, and it's going to be called free rotate. And basically, this will control when the player is in the air, it will be allowed to rotate freely. And when the player is not on when the player is not in the air and is on the ground, it will not be able to rotate freely. So this is gonna be the way we make the gameplay more snappy, so it's not bouncing around the place. Once again, this will be a Boolean by default set to false. And that's the setup for the player. The player has all the variables we need. As a matter of fact, that's all of the variables we need in the whole entire game. The next thing we want to do is go to the project manager, and we're going to add an extension. Now, we only need one extension in this project, and it's going to be called the first person camera. Now, you may be wondering, we're not making a first person Geometry Dash. We could do that, and you can if you want to, But the camera view is not going to be first person. So you're probably wondering, why are we using the first person camera instead of the third person camera? Because if you're aware, there's a third person camera extension as well. And the reason is because I tested the third person camera and there's no angle where it can get kind of behind the player. I'll show you later, but when we actually have the angle for the camera, the third person camera cannot reach that angle. It cannot reach every single desired angle that we want. So we're going to be using the first person camera. It has much more freedom. In my opinion, it's better if you want to access all angles, but the third person camera can still be useful. But I'm going to be using the first person camera because I have the most freedom. So here we have it, the first person camera. You don't need to add to any objects. We'll just have it in the extension right there. So that's the first part that we have. The next thing we want to do is actually start getting into the programming of the player. But before that, let's preview and see what's actually happening. You'll see that we have a problem already. Our player is falling through the ground. And that's because we didn't make our ground a physics object. Because physics objects only collide naturally with other physics objects. So I'm going to add a behavior to ground. And this is also going to be a physics object, so put physics engine 2.0. This will not be dynamic. You want to put this as static. Static physics objects will not ever move. Kinematic physics objects are kind of like static. They won't move unless they're acted upon by another force. But since we never want this to move, we want to keep it as static. We want to set it as a fixed rotation. We're not going to move it. And it can sleep. Once again, better for performance. And for the density, we're going to keep it the same. Friction, it doesn't really matter. We don't want our player to be slippy slidey. So we're going to keep that little bit of friction. We don't want it to have restitution either. Because just because the player doesn't have bounciness doesn't mean the ground doesn't have bounciness. So we want neither of them to have bounciness. The gravity scale, this doesn't matter. None of these other things matter because the ground won't be moving. And I'm going to hit apply. And we're going to go into our block. And we're going to add the same behavior and the same settings for that block as well. So I'm going to go into physics engine 2.0. It's going to be a static physics object. No rotation. We'll fix rotation. Once again, it's going to be gravity scale of 0. It's not going to move. It wouldn't even matter if we put it there. And we're going to set the restitution as 0. Everything else can stay the same because the object won't be moving. And now once I preview, you'll see that my player actually lands on the ground. So this is already good. Now let's finally get into our first pieces of programming. And of course, the first thing we're going to do is make a jump. So I'm going to right click and I'm going to add and go add an event group. And the reason why I do this is because we can organize the code better. It's easier to read the code and go back and figure out what's wrong with your code. It's just a good practice. But I'm going to call this event group player jump. And the way that you put a condition under event group, you simply drag it and you'll see this line, and you want to make sure the line is going horizontally, more horizontal than the actual event group. So here we have it. Now it's nested inside of that event group. Now let's actually get into our player jumping. Now we only want our player to be able to jump. We only want can jump equal to true if the player is on the ground and if it's within certain angles. Once again, I highly recommend you watch the first tutorial that I made for this, because I'm not going to be going into as deep as an explanation here because I've already explained it before. But we want the player to be on the ground first, and it has certain angles at it in. So let's just start programming it first. So I want to put if the player is in collision with ground. If the player is in collision with ground, and I'm going to put and right here, and the angle of the player. I'm going to put actually right here. We haven't set this up right now, but I'm going to put variable. We're going to go into the player's object variable. So I'm going to click into player first, type in variable, and we're going to go into number variable, and then go where it says angle. Remember, all this angle variable is a rounded form of our exact angle. Is equal to 90. That's the first value. And before we do this, I'm also going to set up our angle rules. I'm going to add a new event. Right click, and I'm going to add another event group. And I'm going to call this angle rules, and these will control a few things. The first thing we want to do is set the variable angle to always be equal to the rounded version of the player's actual angle. So we're going to set no condition because we always want this to happen. We're going to add an action. I'm going to click into player and then variable, change the number variable. I'm going to go down to it says change number variable, and the number variable of course is angle. And we want this value to always be equal to round. So first we want to put round, because we're trying to round a number. And the number that we want to round is the player's angle. So the way that we do this, we put player. And since we want to ask at the player's angle, we put dot. And it's important, don't put this angle. That's our variable. That's why I made it have a lowercase letter. We want to put capital A and then angle. This is different. And then we put parentheses. That signifies that this is the player's actual angle and not the variable. So now the player's angle variable will always be equal to a rounded version of this. And we're going to use this a little bit later, but another thing I want to do is add another angle rule for us so we can have it so when the player's angle is greater than or equal to 360, it resets back to 0. So I'm going to add a condition, player, and then I'm going to put if its angle, if player's actual, and we're going to use the player's real angle, not the variable. If the player's real angle is greater than or equal to 360, and we want this to trigger once, I'm going to add another condition under this and go into trigger once, and we're going to change the angle back to 0. So I'm going to put player now, angle, and we're going to switch it back to 0. And the reason that we do this, because in Gdevelop, it doesn't work like regular things in the real world. In the real world, if we have a rotated object, you know that this only is 0 through 360 degrees. But in Gdevelop, when an object keeps rotating, it keeps adding to the angle, even after 360. So therefore, if we want to be realistic and not have an infinite possible number of rotation values, we want to make sure that resets every time it is greater than or equal to 360. So that's why we're doing this. Now back to this player jumping. We're making sure that the player can only jump if it's within those certain flat angles. Because you'll know that we'll have 90 degrees, you have 180 degrees, and these are like what I call the flat angles of a cube, where the cube will be on its side. And I'm going to paste this again, and we're going to have this as 270, and then the last one is going to be 0. And make sure don't put 360, because once again, the angle will never equal 360 because we keep resetting it. So here we have it. This is the condition on whether or not the player can jump or not. So now we're going to put add action. I'm going to click into player and then go into variable. And we're going to change the Boolean variable can jump, and we're going to change it equal to true. Of course, this won't do anything yet because we actually haven't programmed the jump itself. Because we want to do a few more things before we program the jump itself. Now, and we're not going to do any testing. You want to really follow along closely. We're not going to do any testing until after the fact. So that way we won't be getting confused a lot by doing a bunch of testing. Because right now, none of this will work. So next thing we're going to do is set the condition that sets can jump equal to false. Because we also, if we're going to have it true in a condition, we have to also set it false. And basically when we're not in collision with the ground, we want to set can jump equal to false. So I'm going to put player. I'm going to type in collision. And I'm going to put if it's not in collision. I'm going to put if it's not in collision with ground. And you may be wondering, how do we put not? We just put invert the condition. And that's basically saying if we're not in collision with ground, do such and such. And what we want to do is set can jump equal to false now. So I'm going to go into variable of the player. We want to click into player first. And then I'm going to change the Boolean variable can jump equal to false. And of course, none of this will work yet, because we actually haven't programmed the actual jumping itself. Now let's get into the real jump code that makes a player jump. Now, we want to make a space key jump. I'm going to add condition. And I'm going to go into other conditions. And first we're going to do keyboard, key pressed, space key. If the space key is pressed, what do we want to do? Now, before we just have it, if the space key is pressed, we also have to make sure if space key is pressed and can jump is equal to true. And can jump is equal to true. So I'm going to put if space key is pressed, and I'm going to go into events and control flow, and now we want to put variable. I'm going to go into our player and go into variable, and can jump if it's equal to true. If both these conditions are true, then we want to actually add a force to the player to make it jump. And since we're a physics object, we're going to be adding forces. So I'm going to go into add action, and here I'm going to go into player, and we want to apply a force. And not only do we want to apply a force, basically we're applying an impulse to the player at a certain angle. So here's how we're going to do this. We want to apply an impulse force. So let's add an impulse towards an angle. And the angle that we want is negative 90 degrees. The angle, that's what we want. And the length of it is going to be 4.5. Now, the reason why I told you to have these exact values, because when you change the size of the player, the amount that you need to push the player up is going to change. So if I make this force, if I make the player bigger, this will make the player go less far. Same thing if I change the density of the player. Like, that's a whole nother topic in itself when it comes to physics. But basically what I'm saying is when you change the size of the player, remember, if you're making the player bigger, you want to make this force bigger if you want the value to stay about the same. And if you're making the player smaller, of course you want to make the force smaller if you want the value to be about the same. So these all interact with each other because we're dealing with physics objects and not just regular objects. So the length is 4.5 newtons, I guess. Maybe I think that's the force that they're talking about here. And the application, basically, where do we want the force to start? And when we're dealing with a jump, normally, and most of the time, not all the time, but normally, we want the force to come from the center of the player. That way we'll go straight up and we won't be brought up by one of our corners or one of the sides. And the thing is, we can't use point X and point Y because 3D and Gdevelop 3D objects don't have points. You can't access points on 3D objects. But there's another way to do this mathematically. So I'm going to put player.x. And first we're accessing the players.x. Now this is not the center. By default, the origin is in the top left corner of an object. That's by default. So we don't want the force to be applied from there. So the way that we do this is we want to get the center. And we want this to be flexible. So what I'm going to do is put plus, player.x plus, and we're going to put player.width. This for the x center. Player.width divided by 2. Divided by 2. And this is very flexible code because no matter what the size, no matter what the length of our player is, no matter what the width and what the height, this will always be at the center for x. And if we're going to do a similar thing for the y position, we're going to put player.y. And I'm going to put, instead of plus for y, we're going to put minus. We're going to put minus player.height. And I'm going to put also divided by 2. And we've got to put parentheses after the height. Divided by 2. And by using this code, this will make sure that the force is always applied at the center of the object, no matter how the length is changed or how the width is changed. Of course, this is for a cube, not a complex shape. So this is what actually makes the player jump. This is what actually makes the player jump. Now, another thing we're going to do, this is the player jumping code. I'm going to add another event group. We're going to be adding a lot of these, so get ready. I'm going to add another event group. And this event group is going to be called angle snapping. Once again, I'm not going to go too deep. I have to try hard not to go deep into the explanation. But I explained this in a previous tutorial. But once again, we're going to basically be snapping the player according to these 4 values. 90, 180, 270, and 0, of course. So we're going to be snapping the player's values using some math. Once again, I'm actually going to try my hardest not to explain anything here. I'm going to speed it up. I'm not going to speed it up too much so you can see it, but I'm going to speed up me putting in this code, and you can follow along. If you want explanation, just make sure to watch the previous tutorial. So I'm going to speed this part up. So here we have it. This is the angle snapping code. Once again, you want to make sure you be careful when putting in this code. It's super easy to mess up this part because it's very tedious and you have to do a lot of changing of values and to make sure that everything is correct with each other. But if you get stuck, I do have the source code in the description on my GitHub page just in case you can't really figure out what really happened. But I recommend that you try to troubleshoot because that helps you become a better programmer when you try to find the bug on your own. But now that we have this angle snapping, once again, we're not going to test anything yet. We just really have to pray that this all works at the end. But as also part of the angle snapping, I didn't talk about this yet, and that's the free rotation. That's free rotation. Now, once again, like we said that when the player is not colliding with a jumpable, when the player is basically not on the ground, it's going to be in free rotate mode. Also, when it jumps, it'll be in free rotate mode. And also, when it's not on the ground, like we just said, when it's falling, it'll be in free rotate mode. So the first thing we want to do is actually start setting up free rotation. Now, of course, we said the first condition is going to be when the player jumps, we want free rotate to automatically be equal to true. But before we do that, I'm going to set it so the fixed rotation, let me just put it right here. The fixed rotation will be off when free rotate is equal to true. So I'm going to make it so add a condition. This is going to be under angle snapping because it's kind of related to that. I'm going to add condition. I'm going to go into other conditions, events and control flow. Not events control flow. We're going to go into player variable, and we're going to go into Boolean variable free rotate, and we're going to put if free rotate is true, if free rotate is set to true, and I'm going to add an action here. I'm going to go to player, and then I'm going to go into angle and add an angle. Now, for my testing, when you try to rotate something that's that's fixed rotation, it doesn't work. But you can try it out yourself just in case. But you have to directly change the angle of the object. So when we have free rotate mode, we're gonna change the angle by 1.8. Once again, these are tested values. You can tweak these if you don't like them, but for my testing, these work great. So now we have it so when free rotate is actually equal to true, then it'll actually do something. So now that we have that set up, we want to make it so when the player jumps, we want to set free rotate equal to true. So I'm gonna go into player, type in variable, go into Boolean variable, free rotate is equal to true. Now, of course, that means we need something to tell the game the set free rotate equal to false as well. So basically, when the player is on the ground, when the player is colliding with ground, we want free rotate equal to false. But before we do this, you might know that we have two things that can collide. We have the ground and then we have blocks. So I'm going to create an object group, and this is going to be called jumpable. And we're going to add this under scene groups, and this is going to be called jumpable. We're going to call them jumpables, almost like Lunchables. But we're going to add this. And the jumpables, these are the objects that the player can jump on, the only objects that we can jump on. So it's going to be ground for the first one, and then it's going to be block for the second one. And also, these will be the objects that will set free rotation equal to false as well. So let's do that. So now under angle snapping, we're going to put if player is in collision. And we're using this collision because remember, both of these blocks are physics objects. So I'm going to put collision. I'm going to put object right here. And we're going to put for this jumpables. If we're in collision with any jumpables, we want to automatically set free rotation equal to false. So free rotation, we're going to put add an action. We're going to put player, and we're going to go into variables, and we're going to change the Boolean variable free rotation equal to false. And also another thing, we haven't set it up so when the player actually lands that it snaps on the ground. So we're going to set it up so if player, once again, if it's in collision with jumpables, we're going to set the angle of the player to be equal to the nearest angle. So I'm going to put player, and I'm going to type in angle. We're not using the variable. We're going to use the actual raw angle. And we're going to set it equal to player, and we want to access the variable nearest variable. So we're going to put player.nearest variable. Well, nearest angle, not nearest variable. And we're going to put this as trigger once, because if we don't put that as trigger once, it will stay stuck on the ground. It won't ever be able to change its angle again. So we're going to put trigger once while true under that as a condition. And one more thing, we want to put if the player is not in collision with, instead of putting ground, we're going to put jumpables. And same thing for this, if player is in collision with jumpables, to make it more flexible. We're going to not only set can jump equal to false, we also want to set free rotation equal to true, because if we're falling, we also want to start rotating. So we're going to set the variable free rotation. We're going to go into variable, change the Boolean variable free rotate equal to true. So now that we have free rotate set up, in theory, things should be working out. In theory, things should be working out. So let's see if things are actually working out or not. So we drop onto the ground, and if I jump, I gotta press space to jump. We already have one issue, and the first issue is that the player isn't actually jumping. Now the real issue right here is that under this condition where we set the angle, we're basically saying the angle has to be equal to all of these, which makes no sense. I forgot to put the or. Basically we want, so if the angle of the player is equal to 90, 180, 270, or 0, then the player can jump. But I said it only has and of course that's an impossible statement, so that means the player can never jump. So let's add, it is a sub condition. So let's add sub condition, and this is going to be an or. And I'm going to drag this or over these angle conditions, and we want to put these angle conditions as a sub condition of the or. So make sure that you have these aligned, and you'll see them kind of indented. They should be more to the right than the or itself. That's how you know they're embedded into that, nested in them. So let's preview now and see what happens. As you see, we can jump, but you see that we just jumped super high. Okay, that's more like it. Now, of course, ran into some more bugs on the jumping, and the reason why we have to set another limit, because basically when can jump is equal to true, we have to make sure that always knows that before adding a force, these conditions have to be true. Not only can jump has to be true, but the angle has to be true as well. The angle has to be true. So, yeah, that's what we have to do. So another thing is we ran into another problem. Now, I know this is very buggy. This is very buggy. But sometimes when you're programming, you run into issues like this. And you'll see that the player is not really rotating as we want it to rotate. And the reason why is a problem is because instead of adding an angle of 1.8, I made another mistake and set it equal to instead of adding. So this would be the last bug that we have in this case. Here we have it. Actually working jumping code. That's just shows the importance of testing as you go. Because that's what happens when you try to type a bunch of code and you don't actually test it on the spot. But now that that's done, the last thing we want to do in this tutorial is set up our camera. Now, keep in mind, this is part 1, because we're not going to do any of the 3D movement that I was discussing earlier. You don't have to worry about me taking forever on part 2, because it's already programmed. All I have to do is just record me remaking it, so you don't have to get stressed about that. But now we're going to add the camera. So, of course, we already have the camera in the scene, but, of course, we're not going to be having it from this view. So we're going to do the camera code. So now when it comes to the camera's not too hard. It's very easy, actually. So I'm going to add a new event. Right click, and I'm going to add an event group. And I'm going to call this event group. It's going to be camera. And we're going to drag this near the top. It doesn't really matter the order where the camera is. Order only matters in specific circumstances. I'm going to drag a condition under this camera. And make sure it's nested inside of here. And the first thing we want to do is make sure that we're looking through the camera's eyes. We want to look through this object's eyes. Just pretend like it has eyes or something, but we're looking through its eyes, assuming that it has eyes. So we're going to have this as an always condition. We want this to always be true. And I'm going to add an action, and I'm going to click into, actually we don't have to click into anywhere. I'm going to go into where it says other conditions. Never mind, I just lied. You do have to click into the actual object. I'm going to go into click into camera. I'm going to go into where it says look. Let's see if I can find it. Yeah, look through the object's eyes. And we want to look through this camera's eyes. And of course, I'm going to have this on the base layer. That's the only layer we have. So if I preview this now, you'll see that things are sideways. And of course, I've dealt with this problem a billion times. I have a tutorial on literally dealing with this problem. It's a very simple fix. Go into the camera's coordinates, and in the object values, go into rotation X and put -90. This will flip his view. So I'm going to put preview, and now we actually have it more as we want it to, and then in an actual more desirable state. This is not exactly how the game's point of view is going to look, but we'll tweak that some more in the next tutorial. But we also want the camera to always be hidden. We don't want to ever see the camera, so I'm going to put always. I'm going to put camera. I'm going to type in hide. We want it to always be hidden. And another thing, I'm going to add a new event just in case we want to tweak these as well separately. But this is also going to be an always condition. Now we're going to be setting the camera. It's always going to be at a set position from the player. It's always going to be a certain distance from the player, even if it's moving, even if the player's moving. So I'm going to always, and I'm going to go into add an action. I'm going to add an action first, and I'm going to go to the Y position of the player. Let's start with the Y position. Let's start with the X position. You know, X be coming first always. So let's go into the X position of the camera, and we want the X position of the camera to always be equal to player.x, and not just player.x. We want to be behind. The player. So I'm gonna put minus. There's a value that I've already set up. Once again, you can tweak these if you don't like it. Minus 634. And I'm gonna copy and paste this, and we're gonna put the same thing, not the exact same thing, for the Y position. We're gonna put player.y minus 118. And for the last one, I'm gonna add an action, go into player, and we're gonna put the Z position of the player. So it's going to, it says elevation right here. We're not using it for elevation. It doesn't matter. But we're gonna set it equal to player.z plus 175. And the reason why I'm doing this is because we want it to be kind of looking from the side, because it's directly behind it. It's kind of wacko. So let me you can't really see the player right now. And another problem that's set up. Another problem, it's the last bug. I was changing position of the player to be equal to these values instead of setting the position of the camera to be equal to these values. Once again, my apologies. A lot of things are bugging out, but of course I'll have it edited in a way where you won't see all this pain that I'm going through right now. But here we have it. This is the camera view that we're going to be using for our game. This is the camera view. And of course our player's not moving. It's very easy to add movement. What we'll be covering in the next part, which is going to be the last part for now, is the sideways movement, sideways falling off, the objects that can kill us, and making sure that all works in a realistic 3D way. That's what we're going to be covering in the next video. So I hope you all enjoyed that video. This is 3D Geometry Dash. Once again, please watch my previous tutorial if you haven't already so you can understand things better. But this 3D Geometry Dash project is very ambitious, and I'm going to be continuing with it even after the tutorial. But if you enjoyed the video, please like, subscribe, comment down below what you liked about it, what things you didn't like about it. Just comment down below feedback, and also other tutorials that you'll like to see in the future. I'm also going to have my members in the description below. My member, I want to thank my member for support, and I hope that you all can become members. I'm offering my membership for $0.99 a month, and you get access to priority replies. You'll get early videos. You'll also get early screenshots and sneak peeks of what I'm working on before they even come out, special badges and things in live streams. But that's all at $0.99 a month, or just because if you just want to support the channel so I can keep making these tutorials that I make all the time. So once again, I want to thank you all for watching, and I'll catch you in the next tutorial. See ya.